Hello, all. Good evening. Welcome to Career Launcher and welcome for the session. Well, 150 must do questions. So, this is the time that we should be gearing up in full pace. And the idea is to discuss the most expected questions, uh, concepts which are often tested and are most expected, and also throwing in some new concepts along the way because as we know, cat is known for its surprises, so we must be uh, willing to take up the new challenges, right? So uh, it will be a mixed bag of problems and questions that we'll go through, and in all the sessions we'll be keeping a mix of the different topics. Okay, so I hope all of us are geared up, and let's dive into the problems. Okay, here we go. But first, just to remind you that CL is out with its app, both on iOS and Android. So make the full use of it, I would say. Live classes, practice with CL, MBA Profiler, and Profilizer, in fact. So it makes your profile and study material. Right, so download it and make full use of it, right, as you have been staying in touch with us. Okay, now let's see, here we go. Okay, so question 1, percentage. Let's see. I'm waiting for your answers, by the way, so if you are faster than me, let's see, right, let me know on the chat box. Okay, from 2018 to 2019, Geeta's salary increased by 25%. But from 2019 to 2020, it reduced by 10%. So it's obviously a problem on successive change. First an upside of 25%, then a downside of 10%. For the same time period, Nita's salary first had a drop, it decreased by 20% and then increased by 35%. Now, okay, fine. If Geeta and Nita earn the same salary in 2020, which is the last year, so from 18 to 19, 19 to 20, in 2020 their salaries are the same. Then the question asks for comparing their salaries in the initial year, which was 2018. So the final values are the same. The initial values have to be compared, and the initial value to the final value, there's a successive percentage change involved. So clearly, it would be helpful to make use of the multiplying factor idea, right? Okay, so let's say we take x and y for the salaries of the Geeta and Nita respectively, right? X is Geeta's initial salary in 2018 and Y is Nita's initial salary in 2018. So what happens to X? So we'll directly write one single line equation, right? That the Geeta's salary in 2020 matches with that of Nita in 2020, right? So what happens to X? It first increases by 25%. What's the multiplying factor for that? 25% is 1 by 4. So it becomes 1 plus 1 by 4 times, it becomes 5 by 4 times. So x into 5 by 4, and then it decreases by a 10%, right? So 1/10 of a decrease. So it becomes 1 minus 1 by 10, 9 by 10 times. X times 5 by 4 times 9 by 10 matches with Y, Nita's salary in 2018. Then it first decreases by 20%, which is 1/5. So it becomes 4/5, right? And then increases by 35%. 35% is 35 by 100 or 7 by 20 fraction, right? So it becomes 1 plus 7 by 20, which is 27 by 20 times. So the point is, this single equation captures all the information, right? And the idea of multiplying factor helps you to reach there quickly. Let's simplify. What do we get? Uh, so 9 cancels from here. We have 3. 5 can be cancelled over here. This is 2. And 4 can be cancelled from here. This is 5. All right. So anything else? No. What is x by y therefore? So 2 into 4, 8 into 3, 24, and 5 goes over here, 5 into 5, 25. Geeta's salary in 2018 seems to be less than that of Neeta because the ratio of x to y, Geeta to Neeta, is 24 is to 25 in 2018, right? So the very first option says Geeta earns 4% less than Neeta. Yes, that is indeed correct because 4% is 1 by 25. So yes, the ratio of 24 by 25 makes sense, right? 24 is exactly 4% less than 25. So yes. All right. So multiplying factor idea, successive percentage change, right? That helps you to sail through this one. All right. Next one, time and distance. Okay, so who can run fast and solve this question? Let's see who is the first. Okay, I'm waiting on the chat box, right? I'm also starting with you. Let's play the game. Okay, let's solve this. Uh, so it's a question of meeting, right? It's a question of meeting points. Ramu started from town X at 6 a.m. and reached town Y at 2 p.m. 6 a.m., 2 p.m., 6 a.m. to 12 p.m. is known, 6 hours, and then another 8 hours. So Ramu took 8 hours. Somu started from Y at 8 a.m. So he started from the other end. At 8 a.m., reached X at 8 p.m. That's exactly 12 hours. He takes at 8 hours, he takes 12 hours. At what time did Ramu and Somu cross each other? Right? Okay, let's see. So, uh, X to Y, here comes Ramu. He starts at 6 a.m. So, although Ramu seems to be fast, right? Ramu is fast because he's only taking 8 hours, right? He starts at 6 a.m., reaches at 2 p.m., right? So he starts early. So he would have already covered some distance by the time from the other side Somu comes, right? This is Ramu's direction. Somu is coming from here, starting at 8 a.m. So we obviously need to take into consideration the distance covered by Ramu until Somu starts the journey. But the point is that distance is not given. So the point is, you see, there are a lot of these questions where information seems to be, insufficient. It looks like, okay, where is the distance? Where is the speeds of the two people? But the whole point is that it does not matter. The question to answer this answer can be obtained regardless of the value of the distance. Let me prove it to you if you have any doubt about that. Let's say that the distance we take as some number, okay, as a variable rather, so that we can be sure that whatever that value is does not matter. Uh, what I'll do is I'll not take the distance as a variable x, but a multiple of the time periods, because once I define the distance, I know I have to define the speed also. Speed being distance by time, right? Once I define the distance, then the speed is distance by time. So I need the distance to be multiple of time so that the speed is not in the fraction form. So the time for Ramu and Somu are 8 and 12 hours. LCM of that, I'm looking for a common multiple of 8 and 12 is 24. Let the distance be 24x kilometers. Okay. Let this be the distance 24x. So what is the speed respectively of the two people? Ramu can run 24x distance in 8 hours. So his speed is 3x uh, kilometers per hour, whatever are the units. I've taken it as, let's say, kilometers. So 3x in kilometers per hour. And likewise, the speed for Somu is 24x by 12, right? He can run this distance in 12 hours. So his speed is 2x. That helps me to take into account what happens until 8 a.m. At 8 a.m., Somu is at point Y, and here is Ramu somewhere down the line. having covered some distance, which is 3x into 2 speed into time, 3x speed, 2 hours from 6 a.m. to 8 a.m. So he has covered already 6x distance. The whole distance was 24x. So this distance from this point where Ramu is standing at 8 a.m. Now they are moving towards each other in the opposite directions, right? Now the distance remaining is 24x minus 6x, which is 18x, right? So this distance of 18x has to be covered at the relative speed, which is 3x plus 2x, 5x, right? So simply applying the relative speed concept, the further time taken to meet after 8 a.m., right? After 8 a.m., the further time taken to meet is that the distance 18x has to be covered at the relative pace of 2x plus 3x, which is 5x, which is coming to be 18 by 5 hours. So hence proving my uh, assertion that this x is irrelevant. It eventually cancels away, you can see over here. So we're getting 3 and 3/5 of an hour that would be taken further after 8 a.m. 8 a.m., 3 hours, 11 a.m. 3/5 of an hour, 1/5 of an hour is 60 by 5, 12 minutes, 12 into 3, 36 minutes. So this means they will meet at 8 a.m. plus another 3 hours and 36 minutes, which means this is 11:36 a.m. Right? So, right. I could have made this question, a bit difficult by putting in an option of cannot be determined. And maybe some of you might have marked that option. But be very careful. Whenever it seems that something is missing, take that as a variable, move on. Perhaps it will uh, not play its role as it happens over here. Isn't it? All right. So I have not yet got any response, people. What are you doing? Gear up, gear up. Let's see who can do this fast. Right? Let's solve this together. Time and work. Okay, so I'm solving, but also looking at your response if you can get this faster than me or not. Right? Okay. A large water reservoir is connected to 4 pipes labeled A, B, C, D. Wonderful. Pipes A, B, and C can fill the reservoir alone in 12, 32, and 6 hours respectively, while pipe D can empty it in 8 hours. 3 pipes are filling pipes, 1 pipe is a draining pipe. Pipes A, B, C, D are opened sequentially for 1 hour each, such that A works in the first hour, B in the second, C in the third, and D in the fourth hour, and the sequence is repeated. A, B, C, D, A, B, C, D, first, second, third, fourth hour, fifth, sixth, seventh, eighth. So pipe A will work for the fifth hour, first hour, fifth hour, ninth hour, 13th hour. Pipe B will work for second hour, sixth hour, 10th hour, 14th hour. So so they have that repeating sequence. When in which hour does the reservoir get filled? Okay, so time and work, mostly it is easy to take the LCM approach, right? Which means that we define or we quantify the work in this case being the capacity of the tank, right? And in the LCM approach, we take that work to be a LCM of the time periods. All the 4 time periods are respectively mentioned. What's the LCM of the given numbers? 12, 32, 6, and 8 hours, right? Okay, so I guess 96 looks fine, right? 96 is a common multiple of all of these. So therefore, we start by defining the capacity, let's say, of the tank to be some 96 units, right? Just write 96, whatever liters, meter cube, whatever, right? 96 units. Okay. So therefore, we now define the rates. Once we define the work, then we define the rate, right? So the rates respectively are for pipe A, it is 96 by 12, which is 8. positive 8, positive work. Uh, right. Pipe B 96 by 32 plus 3. Pipe C 96 by 6 plus 16. And pipe D doing the negative work. So 96 by 8, which is negative 12. Wonderful. So there is a cycle of work that is being accomplished, right? Means a pattern in, and that cycle is basically consisting of a 4-hour pattern, right? In that 4-hour pattern, first A works, then B works, then C works, and then D works. So in that cycle, what is the work done? The total net positive work done, right? 8 plus 3 11, 11 plus 16 minus 12, 16 minus 12 is 4, 11 plus 4, so 15 units are being filled in that 4-hour cycle, right? But remember, this is not a uniform rate. uh, okay, finally Anshu has given an answer. uh, Good, Anshu. Good. Good. That's correct. Very nice. Very nice. Okay. So 15 units is done in 4 hours. But this is not a linear rate. Remember, this is not linear. We can't say it's 15 by 4 units per hour. Okay. However, it's the fact that every 4 hours effectively you will have done plus 15. But nevertheless, inside of that, it's a up down thing. So whenever we have such question, see, the point is eventually there's a negative work being done. So whenever the tank will be getting filled, it will be always in the upward cycle. It will never obviously get filled in the downward cycle when the negative 12 units is being done. So my point is, think about this, that okay, so my point is, you cannot just say, okay, if see 96 is there, so one common mistake that people do is, now, okay, we need to reach to 96, let's do one thing, let's take closest multiple of 15 up to 96, which is 15 into 6, 15 into 6, 90 units. So make use of 6 such cycles, and therefore 6 into 4, 24 hours done, and finally in the 25th hour, with the plus 8 work that is being done, the tank will be get filled. That is a very common mistake that people do. Listen to me once again. 15 into 6, 90. 6 such cycles of 4 hours each is 24 hours gone. That is what typically people do. And they say, okay, 24 hours done, 90 units done. In the 25th hour, 8 units can be done. So 90 plus 8, we can go up to 98. So therefore, in the 25th hour, it will get done. But the mistake is that there might have been an earlier cycle when at the end of that cycle, whatever work was done, the up cycle, which means 8 plus 3 plus 16 units can be done, maybe the tank gets filled in an earlier stage. So try to follow me what I'm saying. Whenever the work will get done, we need to reach 96 units. Just imagine what can be the maximum work done in the upward part of the cycle. 8 plus 3, 11 plus 6, 27. So what I'm saying is, at the end of some cycle, if even if the tank was filled up to the level which is 96 minus 27, follow me, 96 minus 27, because I have to reach to 96. Okay, I know in the positive cycle I can do 27 units. So even if I'm sitting at 96 minus 27 units, which is 59, right? So I can still reach to the full level of the tank, right? Isn't it? So sorry, 96 minus 27, sorry, 69, right? So even if it is 69 is done, perhaps I can still fill the tank, because then 27 units can be done and the tank will get filled. That's the point. So the target is not 96, the target is 69. If 69 units are done at the end of some cycle, 69 or more, then in the upward cycle, the work will get done. So think of the multiple of 15 either at 69 or beyond 69, which is 75. 75 is 15 into 5. So now we are thinking of ending at the 5th cycle, right? So when 15 units are done 5 times. 5 such cycles are done. 75 units are done. 75 units of work is done. And the time we have taken so far is of 5 cycles, which is 5 into 4, 20 hours. Then, after the 75, we know within the next 3 hours, the tank must get filled because of our backward calculation. So 75 plus 8 is still not there. It is 83. Then 83 plus 3, we are still not there. We are at 86. But so this is the end of the 21st hour. We are not done. This is the end of the 26th second hour. We are not done. But 86, and then we can do plus 16. But we only need 4. So 4 more units can be done in 1/4 of the 23rd hour, because 16 units can be done. We only need 4 units. So in the 23rd hour, the tank will get filled. Very good answer by Anshu on this. All right. So this positive and negative mix of the work, right? That concept is what I'm trying to emphasize. Is something that is a little tricky to understand, but I hope you are with me on this. How to handle this? All right. Perfect. Okay, let's see. We have lots more. Let's move on. Let's bring in something on algebra now. Modulus inequalities. Okay, here we go. How many integer values of x satisfy the inequality given below? How do you do this? How do you handle this? I have done algebra sessions recently, and if you have attended the same, you must have seen that how much I rely, on graphs. I love doing graphical analysis with algebraic problems. Okay, and that is something, again, what I'm trying to emphasize over here. Solving an inequality from a pure algebraic perspective can be sometimes challenging. Sometimes questions are there on inequalities when that has to be done. There have been some questions on that also. But whenever it is possible, whenever you see, an inequality, when on the left hand side and on the right hand side, the expressions which are there, you think that both of them can easily be sketched. We know their graphs, right? So jump to a graphical analysis. That typically helps. Okay, I'm not saying that pure variable based algebraic things don't have to be done. They must be done, but graph supports that analysis. So again, I'm looking out for your response, if you can give me. And here is what I would do. I would read this thing as if I'm looking at an equation which says fx is less than gx, where fx is this quadratic expression with a modulus and gx is this linear functions, right? So let me put them on the graph, and let me analyze what it is trying to tell me. This quadratic is obviously very simply x minus 2 into x minus 4, a very simple factorization. So it has the roots which are 2 and 4. Now the original quadratic without the modulus would have gone below the x-axis. But with the modulus, whatever is its downward part of the parabola will just be reflected about the x-axis and come above. That's the job of the modulus, to make the negative value as the positive one of the same magnitude. So this quadratic expression is going to be um, something of the sort, with the roots and 2 as 2 and 4. So it will come down. It was going to go below, but modulus will make it positive. There will be this portion, and then it will again go up. All right, so I'm trying to keep the colors different so that you can easily understand the graphs. So the blue one is the fx. This is my fx. Now comes my gx, which is a simple straight line, y equals x minus 2. Remember, these were the roots which are 2 and 4, right, of the quadratic. Fortunately, y equals x minus 2 will also pass through this 2, 0. So that is one of the meeting points of the two graphs. Then obviously it's a line of slope 1. So passing through 2, 0, because at x equal to 2, it is 0. And then it will rise upwards. most probably it will have an intersection point somewhere between 2 and 4, and then again somewhere down the line beyond 4 as well. Now I'm looking out for basically those portions of this graph which I will try to shade, in which, so this green line is my G. I'm looking for those portions of the graph where the quadratic is below the linear. Quadratic is above the linear from minus infinity to 2 and even up to this point of intersection over here, which I have not yet calculated, but there will be definitely some intersection over here. Then from this point of intersection and onwards, let me shade this with a bright red color, and the quadratic is below the linear, and even here when it is again rising until this. So basically we have to find these 2 points of intersection, isn't it? So I know what I have to do. I have to identify these points of intersection, this one over here and this one over here. Between this range the quadratic is below the line, and everywhere else it is not. It's a strict inequality. So remember, the end points will also not to be have also not to be taken. Now since I have to solve them, so I'll just open the modulus in its two different with its two different signs, and I will get the two different solutions. Once I will open it as it is, so I'll say x square minus 6x plus 8 equals x minus 2, and the other one I'll get the other point of intersection by solving x square minus 6x plus 8 equals 2 minus x, right? So this one is x square minus of 7x plus 10 is 0, so this is x minus 2 x minus 5. Very simple factorization. 2 we know, yes, already that is one of the points of intersection, but that is not in the picture. So basically I'm getting that other point of intersection farther down the line over here, which is x equal to 5. So this point is basically 5 comma 3, because we are having this line y equals x minus 2. Then comes the other one over here, for which we can solve this. So x square and minus 5x and plus 6 is 0. So yeah, again very easy factorization, x minus 2 x minus 3. 2 we have already taken care of. So this point is x equal to 3. So what is the range? The range is x lies from 3 to 5, non-inclusive of the endpoints. So if you're looking for integer values of x, there is only one integer value of x in this range, which is at x equal to 4, when the quadratic is over here at the level of 0 below the line. Right, so what's the answer? 1. Right, so don't you think, I mean, just give me a yes or a no, people. What do you think? Does this algebraic, does this graphical analysis, doesn't it make it easier to then do the algebraic work, right? What do you say, yes or no? Doesn't it make life easy? Doesn't it help us to conclude and understand what is happening in reality? I think so. What do you say? What do you say? I very much think so. All right. Geometry, people, circles. Let's see the next one. I have promised to give you conceptual questions, right? Questions with concepts, right? So not overloaded with a lot of intensive calculations, but purely good logical problems. So uh, AB is a chord of a circle with center O. Nice. Let's start drawing it. Let's draw a circle. Let's see what we have. Again, remember, it's a race. Who will get there first? I hope you will reach there first. Okay, please, I'm looking out for your answers on the chat box while I'm drawing this circle as good as I can. Okay, so um, right, let's keep it like that. A, B, and this is O. Hopefully we'll need to join O with AB because we are talking of circumcenter of triangle OAB. So let's join that. Okay. AB is a chord circumcenter of triangle OAB lies on the circle itself. Then the area of sector OAB is what fraction of the area of the circle? What is circumcenter? People mostly have this confusion about centroid, circumcenter, incenter, orthocenter is the intersection of which lines. So that you should know, right? If you have read the theory and understood it conceptually, you will always remember this. Circumcenter is the point of intersection of the perpendicular bisectors of the sides of a triangle, right? And circumcenter is equidistant from the three vertices of the triangle, and that is the reason that a circle can be drawn through that and passing through the three vertices of the triangle. So basically we're talking of the circle passing through the points O, A and B. So I'm not going to draw that completely. That's not the point. The main theme is circumcenter is on the circle. Circumcenter is the point of intersection of the perpendicular bisectors of the three sides of the triangle. Right now, the perpendicular bisector of AB, the chord itself, is nothing but the line passing through O and going perpendicular to AB, obviously cutting it at its midpoint, obviously, and that makes let's say this is some point N, and going, and if I extend this line further, so here on the circle, this point should be the circumcenter of the triangle OAB. That's what the question is saying. But at the same time, this circumcenter which I've identified, let's call that C, is also the meeting point of the perpendicular bisector of the side OA. So since OA is nothing but the radius of the circle, so if I'm drawing its perpendicular bisector, let's say it is passing through this point, let's say M over here, which is the midpoint of the radial line OA. So this OM becomes R by 2. And this perpendicular bisector, when extended, must be passing through this point C only. Hence, I can apply the geometry in this triangle OMC, which is a right angled triangle, in which OM is R by 2, half of the radius of the circle. Because MC is the perpendicular bisector of AO, because of the very definition which defines the circumcenter, and OC is also the radius R of the circle. So therefore, I can try to find this angle AOC, this angle theta, because in this right triangle, the OM and OC are known. OM is the base with respect to that angle theta, it's the base. So I can talk of cos theta value, which is cos theta is base OM over hypotenuse OC. Remember, OC is the hypotenuse opposite to 90 degree. Hence, OM is R by 2, OC is R, so cos theta is half, which means theta is 60 degree. The same thing happens here also. This is the identical triangle. So this angle is also theta equal to 60 degree. This ON being the line of symmetry of this isosceles triangle OAB. Hence, the central angle of this chord AB formed at the center is 2 theta, which is 120 degree, which implies that this sector OAB is 120 by 360 degree, 1/3 part of the circle. That's what the question is asking. Sector is what fraction of the circle? 120 degree sector, so it's 1/3 of the circle. Right? Very conceptual, right? No intensive formulas and stuff. Just pure definition of circumcenter that you need to know. My point is, CAT is not a exam of mathematicians, right? Your basic understanding is being tested, right? So know your basics, right? And know how to apply them. Okay, lots of things in store, people, for today. I hope this is again interesting, and we are learning. And let's see the next one. I want some participation now, right? Let's do this one, people. It's something that I think all of us can do. What is the hundredth term of the sequence given below? 1, 2, 4, 7, 11, 16, dot, dot, dot. Yes. What is the hundredth term? I'm giving you a head start. I'm giving you a minute to think on this. Hmm. Okay. Time out. Yes, it should have been done. Okay, I'm still waiting. 1, 2, 4, 7. So typically when you have a sequence, if it does not strike you immediately what's the pattern, the first thing that you should always do, right? That's the mantra always to do. Look at the differences, right? What are the differences? 1 plus 1 is 2 plus 1. 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 4 is 11. 11 plus 5 is 16. A very simple pattern. So sequentially, the differences are consecutive natural numbers 1, 2, 3, 4, 5, and so on. How do you find the hundredth term, by the way? You have understood the pattern, but then how do you find the hundredth term? Now, the idea is not to start to try to find the formula for the nth term, but just follow the pattern. So the first term, I'm just naming the sequence as with letter A. So the first term A1 is given as 1. The second term, so just write it in the way we have achieved it. We have basically added 1 to the previous term. So A2 is 2, which is 1 plus 1. A3 is obtained by adding 2 to the previous term. So again, write it as it was. 1 plus 1 was the second term, and then you added another 2. A4 is whatever A3 is, just write it as it is, and then you added a 3. I'm trying to show you what's happening basically. You think of it as addition of the consecutive natural numbers. Look at this. 1 plus 1, 1 plus 1 plus 2, 1 plus 1 plus 2 plus 3. What will be A5? 1 plus 1 plus 2 plus 3, the fourth term, plus 4. So I hope the pattern is very clear by now what is happening. Second term, 1. So 1 is separate, and then we have added 1. Third term added till 2. Fourth term added till 3. Fifth term added till 4. So 1 less, right? So therefore A100. So 1 is separate, the single one outside, and then what? 1, 2, 3, 4, dot 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 99. 1 less than 100. Pattern recognition, right? That is what is your job in sequence and series, right? So we know all this, how to calculate this. 1 plus the sum of the first 99 natural numbers, which will be n plus 1 by 2 is the formula. So 1 plus and 99 into 100 by 2 for the sum of the first 99 natural numbers. So 99 into 50, 100 by 2. 99 into 5 is 495. So this is 4950 plus 1. So 4951 is your 100th term of this sequence. Right? Isn't it? So pattern recognition, right? Understanding how to write the term so that we can actually just sum it up, right? No formula required. What is the formula for the term? Just do number plugging, right? Just write the sequence in its numerical form. All right. Namaste, namaste, everyone. Numbers, numbers, numbers. You know that numbers topic has made a very strong comeback in the recent years, people. Right? So numbers is something again not to be overlooked. Okay. How many natural numbers n is 5760 over divided by n an integer, but 6000 divided by n is not? Hmm. What does the question say? What is it trying to say? I'm trying to wrap my heads around that. Can you do that? Please, people, I want some response on this. Okay, I'm giving you 2 minutes. Okay, let's try this. Let's try this. People. Hmm. Okay, let's start this. Let's start this. So, what is it trying to say? So, basically, 5760 should be divisible by n. So, n should be divisor of 5760. N should be a factor of 5760. Right. So, this needs to be an integer. So, this n should be a factor of this number. But this fraction 6000 by n is not an integer. So, n should not be a factor of 6000. Right. So, this is a question clearly in factors. So we are trying to find those factors of 5760 which are at the same time not a factor of 6000, isn't it? Those factors of 5760 which are not the factors of 6000 would make this condition happen, isn't it? Yes or no? So from the factors of 5760 we have to remove those factors which are common to both the numbers. From the factors of 5760 we need to subtract those factors which are the common factors of both the given numbers, so that therefore we are left with such numbers which can divide the first value 5760 but not divide 6000, isn't it? So it's a question therefore eventually on counting of factors. But before that, you need to understand this point over here, which the question is trying to imply, isn't it? So obviously, now we need to just prime factorize both the numbers and get this job done. All of us know how to find the factors of a number. But coming to this conclusion on the question is the core logic that you had to understand. So please let me know if I need to repeat this. I can, but I hope this is clear to everyone, right? Okay, so 5760. 576 is 24 square. So this is 24 square into 10. 24 is 8 into 3. 8 is 2 cube. So 2 power 6 from here and another 2 from here makes it 2 power 7. And then 3 square from here and 1 5 from here. Right? That is what 5760 is. What are its factors? What are its factors? Increase the power by 1 and multiply, right? That's the way we find the number of factors of any number, right? Prime factorize the number and do plus 1 on the powers and multiply. So 7 plus 1 2, 7 plus 1 8, 8 into 2 plus 1, 3, and this is power of 1, so 2. 8 into 3, 24 into 2, 48 factors are there for the number. So this thing is 48. As far as the common factors is concerned, the point is all the factors of the highest common factors of the two numbers are their common factors. The HCF is the highest possible common factor. All its factors are the common factors of the two numbers, isn't it? Let me clarify this once again. Let's say I'm talking of the common factors of 24 and 36. Think of small numbers. What will be all the common factors of 24 and 36? 1, 2, 3, 4, 6, 12, which are nothing but the factors of 12, 12 being the HCF of 24 and 36. Yes or no? Right. So same thing over here. Uh, that HCF, the factors of the HCF of the two numbers are the common factors of the two numbers. Right. So therefore, quickly find the HCF. For that, we need to prime factorize 6,000. 6,000 is 6 into 1,000. 6 is 2 into 3. 1,000 is 2 cube into 5 cube. So another power of another 3 powers of 2 and 5 cube. So that is what is 6,000. So what is the HCF of 5760 and 6,000? Look at this and look at this and do the HCF. Take the smallest powers, right? 2 power 4 is smallest, 3 power 1 is smallest, 5 power 1 is smallest, right? 2 power 4 and 3 and 5 is the HCF. How many factors does this HCF have? The number of factors of this HCF is 5. 4 plus 1, 5, and 1 power on 3 and 5, so into 2 into 2, which is 5 into 2 into 2 is what? Sorry, 20, right? 5 into 2, 10 into 2, 20. So 20 are the common factors, and therefore we are left with 28 factors which satisfy this condition. All right, isn't it? So people, divisibility, HCF, LCM, factors, I think all the concepts rolled together in one problem, one single liner. And that is what CAT exam is all about, right? Okay, let's take one last problem, people. Okay, okay. Here's something, some response I would want people to, that this is something that I think most of us should get. Probability, bag X, bag Y, balls, red, blue. Okay, let's dive into this one. Well. Let's see. Bag X, 3 red, 1 blue. 3 are red, 1 is blue. Bag X, bag Y. 1 is red, 3 are blue. 4 balls in each of them. A ball is randomly drawn from bag X, transferred to bag Y. A ball is then randomly drawn from bag Y and transferred to bag X. Probability that both the bags still have the original number of balls of each color in them. When will that happen? When will it happen? Means what drawings, what balls should be drawn in the two sequential drawings, one after the other, from X to Y and then Y to X, which would make this happen? The same configuration still is there. When would that happen? When you try drawing when you're doing the first drawing of the ball, there are only two things that can happen. Either you draw a red or you draw a blue. If you draw out a red and then one red has come over here and increased the number of red balls, what you need to pick back again from the bag Y and put back in bag X. So you are still having the same configuration. Whatever comes in must go out, so that we are still having the same thing. So either you drop out, either you do this, take a red ball from bag X, put it in bag Y, and then again draw out the red ball from bag Y and put it back in bag X. But you could have drawn out a blue ball also, and then again you should have done the same thing. So either you do red and red back and forth, or you do blue and blue back and forth, right? So the required probability is the sum of the probabilities of these two events being done in succession. So probability of red ball from bag X and then in succession, so again red ball from bag Y being drawn in succession. Remember, the number of balls in bag Y have changed by now, so you have to take into that you have to take that in consideration. So this event has the probability which is, so 3 out of 4 is the probability of drawing a red ball in the first instance from bag X. After that, you would have 1 plus 1, which is 2 red balls over here, and total of 2 plus 3, 5 balls actually. So the probability of red ball being drawn in the second drawing from bag Y is 2 on 5. Either you do this, or the other thing, which is blue and blue. Blue from X and again blue from Y, right? Blue from X, probability is 1 on 4. If blue comes over here, then 4 balls are now blue out of total 5 into 4 by 5. So this plus this, which is 4 into 5, 20, and 3 into 2, 6, plus 4, 10, 10 by 20, or half. Isn't it? All right. So I have brought a spectrum of problems today, and that will be the motive of our meetings. We'll be meeting quite soon again, so look out for the next one. Uh, Stay in touch, stay connected, uh, and ask me anything, people. Uh, Keep in touch, right? See you soon. Thank you all. See you everyone in the next one.